I am going to do an exercise of thermal machines. More specific, it's about diesel cycle. For this, I am going to use this board to explain. Yes. Okay, this exercise is the following. A diesel cycle has a compression radius of 20 and begins its compression at 13 psia and 45 Fahrenheit degrees. The maximum cycle temperature is 1800 Fahrenheit degrees. Utilizing air standard assumptions, determine the thermal efficiency of this cycle using A, constant specific heats at room temperature, and B, variable specific heats. Okay, I am going to pass to the board to explain the solution. Okay, we are going to continue with this explanation. In this part, we are going to talk about the analysis of data, of the information, of the video, of the text, excuse me. In this case, we have a fluid that is air standard with some constants or relations. In this case, K, that is a constant, 1.4, Cp, 0.24. With these units are so important. Cb with this value, and the units are the same. Okay, for other part, we have compression radius of 20. Yes, but what is this? This is volume 1 divided by volume 2, and the same equal to volume reduce 1, volume reduce 2, and this part we are going talking later in the part of the in the B part of the exercise with remember variable heats. Okay, now temperature conversions that are passed to the Fahrenheit degrees to Rankine degrees. In this part, we take this value, that is the value of the temperature 1, it's 45 Fahrenheit grades, and plus 460. And with this conversion, this temperature equal to 505 Rankine degrees. And the same process with this temperature. The maximum temperature, remember, is the I named this temperature like T3, equal to this conversion, and the result is 2260 Rankine degrees. Okay, we are going to continue with the other process, with the diagrams. Well, the diagrams TS and PV are them. In this part, this process is a pressure constant process, and this is a volume constant process. In this part, we are going to talk about a compression process, and in this of 3 to 4, is a expansion process. In this is similar, but the variables are pressure versus volume. Yes. These diagrams are very important because summarize the problem basically. Okay, in this part, first we are going to start with the part A, that is solution with specific heats. In this solution, we are going to talk about process. In this case, process 1 to 2, that is isentropic compression. And in this process, we are going to use this equation, that is temperature 2 equal to temperature 1 times for the relation of volume 1 2, that is the same that say the compression radius. Remember, that is this same, and high to k minus 1. Replace values, and the result is this: to temperature 2, 1673.8 Rankine degrees, and similar to the pressure 2, that is this value. Okay, and replace values for this equation, that is pressure 2 equal to pressure 1 multiplied with compression radius high k is this. High, remember, is 1.4. And for the process 2-3 is heat addition to pressure constant. And in this process, in the diagram, you can comprove this is the heat addition is the relation Cp times factor of temperature 3 minus temperature 2, and replace the values, and the heat addition is this 140.7, and the units, English units, I forgot in the last part of the video mention, that is this exercise use the English units. Okay, and we can constant that the pressure 3 is equal to pressure 2 for the diagram, remember, or return the video to comprove this value and this equation. Well, to conclude with this develop the solution with specific heats, constant specific heats, is that with the process 3 to 4, that is a process, isentropic expansion is the process. Remember the diagram. And why isentropic is because the entropic is constant. The name is isentropic. Okay. here we need a relation of good. Yes, it is temperature 3 divided by temperature 2, and equal to the result, yes, 1.35. Next, we need use this equation, that is temperature 4 equal to this divide of relation of good divided by compression radio, high to k minus 1 time to temperature 3. Okay, this result replace them values, and this result is temperature 4 is equal to 768.83 ranking degrees. Then we need use similar equation but calculate the pressure in the 4 point. Yes, and is practically the same equation. Change, for example, the height, the elevator. Yes, is now k, just k, and is the same relation, times for pressure 3. Yes, replace values aquí, here, and the pressure 4 is equal to 19.79 psia. Yes, remember the units of the pressure. So we need to calculate the rejection of heat. This is the process for 2-1, and this process is to volume constant. Okay, in this process we need use Seebeck relation, and this is factor for temperature 4 minus temperature 1. We replace values and found this result, that is 45.12 in the units. And finally, we need calculate, that is the purpose of this exercise, the thermal efficiency. Finally, that is 1 minus the rejection of heat divided by addition heat, and replace values again, and remember this number. Yes, that is the addition heat, calculating the last part of the video. And this thermal efficiency, the result is 67.93%. And that's all for the first method, that is with constant specific heats. Okay, now we need do this process, but with a change in the method. Right now we are going to continue with the exercise in the part B, that is this solution, but with other method that is with variable specific heats. Well, we are going to continue with this analyzed. In this part, we are going to start with the process solution with variable heats. In this part, we are going to use is the complete is a different analyze. For example, we are going to try to focus this table. It's in Spanish, but is these tables, yes. And in this, we are going to search this port. Is the table A line 17E. Is this? Want to try focus? Okay. Is this port? And in this, with this table, we are going to find the different values. Okay. For example, we need first the value of the volume, reduced volume in see the table in this port. Yes, the between 500 and 520. Yes, because between these two values we need found our value of the here. Excuse me, change a little the zoom of the camera. Yes, the focus camera is this temperature between 500 and 520 are the corresponds these values is one. Excuse me, this and this. Yes, between these values we need to find this value that is the reduce of volume 1. Yes, to start this exercise for this method. And okay, if you analyze this value between with interpolate, we need to interpolate these values to find this value. So we found this value of this way. We can interpolate in a calculator, yes, or in a program online in the internet, and found this this value. Reduce volume of reduce with the function of the temperature 1. In this case, interpolate these values, then I calculate this value 170.82, and this is the value to volume reduce of 1. And with this value, we can to calculate the volume reduced to, that is 8.541. Yes, is this with the volume reduced divided by compression compression, I forgot, compression radio, yes, that is 20. Yes. Now I want to explain you the other table. The interpolate table is this. To continue with the process, in this, yes, interpolate in between these values. For example, we found that this is the beer 2, reduce volume 2, yes, and we need interpolate because this number isn't in the table directly, yes. Interpolate, we need interpolate, and it's the same process with these values, but now with the temperature and the enthalpy. Okay, we need to next with the other explanation. To continue with the part B with variable heats, I have that the table A17 bring us the different terms that we need. So we need to calculate the other values like temperature 3 and volume of reduced 3. And this temperature 3, this temperature 3 give the text give us this value, and with this value we calculate these both values, enthalpy 3 and volume reduced 3, yes, are this with the table and interpolate with this value, yes, and in the same way that in the last video, part of the video. In this part we need to calculate the addition of heat. In this case is similar to the previous, enthalpy 3 minus enthalpy 2, and this result is 1,186.51 with these units that are the English units. No? Then we need to calculate the relation code. Do you remember this relation to calculate the volume reduced 4? That is this. And with this value we need to calculate with the table the temperature 4 and enthalpy 4. Yes. With the enthalpy 4 we can calculate this the rejection of heat. Remember, we need these two heats of the addition and the rejection heats for calculate the efficiency of the cycle. Okay, to conclude this exercise, we need to calculate the thermal efficiency of the cycle, of the diesel cycle. To this, we need to calculate before the addition heat and the rejection heat. Yes. Okay, we use these heats in this equation and found finish the exercise the thermal efficiency. That the result with this method is 50.16%. Yes, is less than the efficiency for the method A, that if you remember, if 67, yes, more or less. And of this way, I conclude this video, and I hope that it like you. I don't know. Thanks.